Your car was designed to break within 10 years. That's how the industry profits. Tesla's Model 2 changes everything. Leaked reports show it's built for 30 years. Battery rated for 8,000 plus charge cycles. Corrosion-proof frame. Only 17 moving parts versus 2,000 in gas engines. If they can build a 30-year car now, why haven't manufacturers done this before? And could this really be the last car you ever buy? Your Honda or Toyota isn't breaking down by accident. Every component has a calculated lifespan, designed to fail just outside warranty, but early enough to keep you dependent on service networks. The average gasoline car owner spends $1,200 annually on maintenance after year 5. That's $12,000 over a decade before anything major breaks. The pattern becomes clear when you examine engineering choices. An internal combustion engine requires over 2,000 moving parts, each wearing at different rates. This isn't a design flaw, it's the business model. Complexity creates dependency. Oil changes aren't scheduled every 5,000 miles because oil degrades that fast. Synthetic oils easily last 15,000 miles. The schedule exists to establish recurring customer contact, creating opportunities to identify additional repairs. Tesla's electric motor contains only 17 main moving parts. When you eliminate 99% of components, you're not just reducing maintenance, you're destroying the economic foundation that profits from vehicle aging. This raises an uncomfortable question. Would any manufacturer voluntarily design products that eliminate 90% of their long-term revenue? Understanding this helps explain why traditional automakers possess the technology for 30-year vehicles, but have never built them. Tesla isn't constrained by existing dealer networks or service bay investments, allowing them to build longevity without cannibalizing their own repair infrastructure. Durability starts during assembly, not after purchase. Traditional plants accept panel gaps of 2 to 2.5 millimeters. Over 10 years, those gaps allow moisture penetration, leading to rust formation, water damage, and eventually $800 repairs for weathering issues. Tesla's Model 2 maintains gaps at 0.4 to 0.6 millimeters using Vision AI, but the real innovation lies deeper. Their Statistical Process Control 2.0 uses approximately 1,800 sensors, continuously monitoring every robot movement. When a bolt gets tightened, sensors measure torque deviation to 0.1 Newton meters. Any drift triggers immediate line stoppage, catching errors at the source rather than after customer complaints. This matters because loose bolts create vibration, which induces fatigue stress in surrounding components. Over 50,000 miles, those microstresses accumulate into cracks, then rattles, then failures requiring expensive service 5 years later. Tesla's data shows 50 to 70% reduction in post-production issues, fewer owners experiencing warranty repairs or premature degradation. That dashboard rattle in your current car? It started as a 0.5 millimeter misalignment during assembly. The door that doesn't close smoothly? Hinge torque was off by 2% at installation. These aren't defects you caused, they're built into the vehicle from day one, slowly revealing themselves as it ages. The analysis reveals automotive longevity isn't primarily about materials or technology. It's about manufacturing precision and willingness to invest in prevention rather than relying on repair revenue. Current lithium-ion batteries handle 1,000 to 2,000 charge cycles before degradation, roughly 200,000 to 400,000 miles. Industry sources indicate Tesla is exploring aluminum-ion chemistry for Model 2. Laboratory testing shows aluminum-ion cells potentially achieving 8,000 to 10,000 cycles. If each cycle provides 250 miles, you're looking at 2 million to 2.5 million miles of theoretical lifespan. Even with 25,000 annual miles, that battery could outlast 80 to 100 years. But laboratory performance and real-world durability often diverge. Which brings us to temperature resilience. Lithium batteries degrade faster in extremes. Minnesota winters or Arizona summers cause 30 to 40% range drops and accelerated aging. Tesla's aluminum-ion Focus includes stable operation from -30 to +50 degrees Celsius without accelerated degradation. The financial impact is substantial. Current EV battery replacements cost $8,000 to $15,000. If your battery fails after 8 years, resale value collapses. With Model 2's chemistry potentially lasting 20 to 30 years, you could sell that vehicle in 2045 with 85% capacity remaining. Fast charging introduces another degradation factor. Rapid charging generates heat, causing internal components to expand and contract quickly. Over hundreds of cycles, this creates micro-cracking in electrode materials. Model 2's battery system focuses on stress distribution, spreading charging heat across cell structure rather than concentrating it. You can fast charge regularly without systematically destroying your battery, something current EV owners learn to avoid through experience. What this reveals is that EV longevity isn't limited by technology, it's limit. If Tesla casts the entire underbody as one piece, what happens during accidents? This concern seems legitimate until you examine the engineering. The cast frame isn't solid. It incorporates layered crumple zones designed to absorb impact in sequence. Tesla's crash simulation data indicates only severe impacts require full frame replacement. For typical incidents, repairs remain localized to bolt-on components. The Model 2 frame achieves torsional rigidity around 65,000 to 70,000 Newton meters per degree, significantly higher than Model Y. This describes how much force is required to twist the chassis. Higher rigidity means less body flex when hitting potholes or rough surfaces. This matters because body flex determines long-term durability. When your car hits a pothole, the structure twists slightly. Over 150,000 miles, these movements accumulate. Traditional construction eventually develops squeaks, misaligned doors, and leaky seals as attachment points loosen. A stiffer frame dramatically reduces these micro-movements, keeping doors aligned and cabins quiet for decades. Traditional unibody construction uses hundreds of welded joints. Each weld creates a heat-affected zone where stress concentrates. Over years, these zones develop micro-cracks that compromise integrity. Single-piece casting eliminates these weak points. The aluminum cools uniformly, creating consistent grain structure throughout. Some engineers suggest this frame could outlast every other vehicle component. Tesla applies Gigavel Ultra coating, tested to resist rust for 25 to 30 years, even in heavy road salt environments. Rust is the silent killer of longevity, weakening frames invisibly until minor accidents reveal catastrophic damage. Proper prevention means Model 2's frame could genuinely outlive multiple powertrain replacements. Most buyers compare upfront prices without calculating ownership costs. A Toyota Camry at $25,000 appears competitive with Model 2's $25,000 estimate. Over 10 years, that Camry requires approximately $17,500 in gasoline, $1,500 in oil changes, $3,500 in scheduled maintenance, and $2,800 in unscheduled repairs. Total cost reaches $50,300. Model 2's calculation looks different. Same $25,000 purchase, but electricity costs drop to roughly $4,875. Tire replacements add $1,200. Minimal maintenance for filters and fluid adds $800. No oil changes, no transmission service, no exhaust repairs. Total cost approximately $31,875. The difference represents $18,425 in savings over 1 decade. Nearly $2,000 annually, you're not bleeding on maintenance. But the real value transcends spreadsheets. It's not budgeting $150 monthly for unpredictable car maintenance funds. It's not experiencing that sinking feeling when warning lights appear, knowing you're facing diagnostic charges and expensive repairs. It's not calling in late because your car wouldn't start. These stress factors carry real costs to health and career that financial models can't capture. The analysis also reveals gasoline vehicles appear affordable because true costs are hidden and delayed. You pay $25,000 up front, then bleed another $25,000 in small increments over years. Safety ratings focus on crash tests, but real-world safety depends on accident prevention features. Model 2's low center of gravity from floor-mounted batteries reduces rollover risk by 40 to 50% versus gasoline SUVs. Door hinges use anti-sag alloy tested through 300,000 cycles, ensuring smooth operation for 30 years, crucial for aging drivers with reduced strength. Adaptive lighting illuminates 400 meters ahead while automatically dimming to avoid blinding oncoming traffic, giving you 2 to 3 seconds more reaction time. Regenerative braking adjusts from strong to nearly none, letting you adapt gradually rather than forcing uncomfortable, immediate changes. Tesla hasn't officially announced Model 2's launch or opened reservations. If someone contacts you claiming you must reserve immediately, that's fraud. Tesla announces exclusively through official channels. Reasonable predictions fall between the second quarter and the fourth quarter of 2026, but Tesla has delay history. Cybertruck was announced in 2019 for 2021 production, actually delivered late 2023. Expect delays and don't believe insider timelines. Model 2's broader significance extends beyond one vehicle. When one manufacturer proves 30-year vehicles are viable, others face uncomfortable questions about why their products need constant maintenance. If Model 2 succeeds and owners share maintenance-free experiences, it exposes the entire repair ecosystem traditional manufacturers depend upon. Why do cars need oil changes every 5,000 miles when synthetic oils last longer? Why do brake pads wear out quickly when regenerative braking proves they can last 150,000 miles? These questions become harder to deflect when alternatives exist. This explains fierce resistance from dealer associations and repair shop lobbies. Model 2 threatens. Here's the reality. Building 30-year cars was always possible. The question was economic. Vehicles lasting decades destroy repair revenue, keeping manufacturers profitable. Tesla bets customer loyalty beats repair bleeding because they're not trapped by dealer networks. If Model 2 delivers, traditional manufacturers must either admit they engineered planned obsolescence or invest billions redesigning around longevity. This explains dealer resistance. Model 2 threatens their business model. This is just the beginning. Early adopters gain massive cost advantages before competitors catch up around 2030 to 2035. My question, should regulations require minimum durability standards? Drop your perspective below. If this gave you clarity, hit like now. Subscribe to Tesla Zone for deep analysis beyond headlines. Tap the bell for our next breakdown on manufacturing innovations, cutting costs 50%. This is Tesla Zone. Model 2 proves a future where vehicles serve owners for decades, instead of owners serving vehicles through endless maintenance.